Hello, sir. Today we want to explain the code that we uh, make it for the optimal distributed generation and optimal capacitor, depending on the objective function that we agreed with each other. So as you see here, we have three cases: the base case for IEEE 10 and the base case for 14 and 33. It is the same all, but the difference between that it is the network specification and the load flow for 10 and 33 it is the same, but for the 14 it is different. But we want to explain the first the IEEE 10 bus base case. If you open that file, we have four files here. So the first one, it is the line data. This is the line data, and this is the load data for each buses. And the two other file. The first one, it is the base case, the main code, and the last one, it is the load flow program for IEEE 10 buses. If you open the line data, as you see here, we can find the specification of the line of the IEEE 33. As you see here, this is the first column, it is the number of line. The second, it is the sending in of each line, the sending in bus. And the third one, it is the receiving end bus. And the fourth one, it is the resistance of each line. And the last one, it is the reactance of each line. As you see here, line 7, it is between bus 7 to bus 8. The resistance, it is 0.3885, and the reactance, it is 0.222. The other file, it is the load data. The load data, it is from 1 to 10. This is the number of bus, the first column. The second, it is the real power of each buses, the load. The last one, it is the reactive power of each buses as a load, as a reactive power. This is the specification file of each for the network. In the next video, we will go to the other two files. We hope it is clear. Okay, this is the second video for explaining the code of the base case of IEEE 10 buses. We open the base case. As you see here, the base case of the mini program, it is two things. The first thing, it is the load flow program, to call the load flow program, and the second thing, it is to print the result, as you see here. The load flow we will explain later in the next code tab, but here we want to explain now the result of the program. The result of the program, as you see here, the power loss. You can see here the power loss of network for the base case, the reactive power loss, as you see here, and the voltage profile index also here, and reliability index, as you see here, and the energy not supplied, and the minimum voltages that we get from the network. And after that, we also printed or figured the voltage for each buses. This is the result. And if you go to the load flow program, if you open it, that as you see here, you can the output from this program, it is the power loss, the reactive power loss, the voltage deviation or index, the voltage profile, the reliability index, and energy not supplied from this, the load flow. If you started with the load flow program, the first thing, it is to initial parameter dependent on the call the load data and call the line data, the network data, mean that. And after that, preparing that data to account the number of branches, the number of buses, and determine some other factors, and also the MVA pace voltage, MVA pace, and pace voltage, and pace impedance. And after that, we calculated the per unit values for the resistance and reactance. And then also we calculated and located the load for each buses, the real load and the reactive load, and dependent on the pace MVA. And after that, we started the program from here, from line 31 until line until line 150. It is to arrange the network to be the radial network, and to arrange the buses and how the number of paths in this network, and the number of branches, and arrange it dependent from the sources to the load. And after we arrange that, now we calculated the voltage current program. From here started, the first thing it is to assume that all the buses at all the voltage at each buses, it is one as assumed. And after that we calculated the current in each line, as you see here, branches current, and then accumulated each branches current in each other. And after that we calculated for each branch the accumulated current. And after we accumulated the branches current, now go back to calculate the voltage dependent on the branches current, and repeated this process about 10 times to reach that we can to reach the correct branches current and the voltage bus. And after we repeat it 10 times, now we exit from the group and printed the voltage bus and the current, and started to calculate the losses dependent on the branches current, and the resistance and the reactive power dependent on the reactance and the branches current, and then we accumulated as you see here. And after that we calculated the voltage stability index and the power flow in each line, and power flow in each line, and after that we started to calculate the voltage profile index as you heard, dependent on the voltage that we calculated in the previous process. And then we equal between the power loss, reactive power loss, and voltage profile, voltage power index. And then after we finished that, now we calculated the reliability index as you see here, from dependent on your reference paper. And after that we calculated also energy net supply dependent on your reference paper. And after that we go back the output and printed from the main program. As you see here, you can, if you run the program, as you see here, this is the voltage profile for the IEEE 10 passes for the base case, as you see here. And also you can see the result, the power loss, the reactive power loss, voltage profile index, and reliability index, energy not supplied, and minimum voltage. As you see here, this is the value for the base case IEEE 10 bus. As you see here, there is no distributed generator on capacitor here, because it is base case without any distributed generator or capacitor. So this is the finished of the explain of the base case IEEE 10 base case and the result. Next video we'll go to the 33 bus because it is similar to IEEE, but the different it is the load data and line data for the network. Thank you very much. We hope it is clear. If you have any question, we are ready to answer you, and we will go help you if you have any problem in your understanding. Thank you very much.